Hey folks, how's it going? This is Mr. Murray coming to you with an optional but highly recommended do now for Course 2 honors for March 27th, 2020. Okay, so at this point, hopefully you've started to delve into how we're finding bearings and distance. That's how we're taking it one step further. And so I thought I'd provide this little enrichment activity just to see if you're going on the right track so that you know whether you're doing the right thing with finding a bearing. So again, if you made it here, thank you very much. I appreciate your persistence. I appreciate you continuing to work with me. And I hope you find that not only are you able to do this and do it correctly, but that it continues to reinforce what we've been doing. So again, thank you. All right, so here's the situation. Archimedes is on the hunt for Pythagoras. At 9 a.m., he, Archimedes, takes off in a plane from Logan Airport with a bearing of 36 degrees and travels at a speed of 600 miles per hour. 2 hours later, he changes course and heads due south at the same speed. Find his bearing and distance from Logan Airport at 3 p.m. Okay, so what I want you to do is I want you to think about our problem-solving process. 1, identify the information. 2, draw a picture. 3, get your triangle set up. 4, find the required information. Okay, so please pause the video. Do your best to solve this problem. All right, and then when you're ready, unpause, and I'll show you how to solve it. All right, so here we go. So here's what I see. I see a starting time of 9 a.m. I see an original bearing of 36, and I have to remember that 36 degrees, because I don't have anything specified, that would be north and east, so it's north 36 east, okay? And that is my initial bearing. We got to remember that. If you don't remember that, go back and take a look at like the Google Hangout video, some of the stuff from earlier in the week, even the handouts. Really important to know this, okay? And he's traveling at a speed of 600 miles per hour, okay? So then I know 2 hours later he's going to change course, and so I think 2 hours after 9 a.m., that's 11 a.m., okay? And he's now going to head due south, so I know like straight quote-unquote down, still at 600 miles an hour. That's good. And I need to know, I'm going to highlight this in another color. Remember, I always recommend you highlight what the part where they're asking you to find stuff, okay? Because when you do that, in the end, you can know whether you're providing the information you asked. This is a big skill with like the SAT, because one of the areas that really jam you up is they get you to do a lot of work, and then boom, you report an answer, but the answer wasn't necessarily what they were asking you to find, the thing you're answering. They kind of trap you in to answering something from an intermediate step. Okay, so really important that you always make sure you're answering what you were asked. So in the end, I have to have a distance number and I have to have a bearing. Okay, so let's set this up. So here's my starting point. This is going to be Logan. I'm going to label this L for Logan. Okay, this is due north. Remember, always label your compasses. And now, boom, he's taking off. Okay, the bearing is 36 degrees east of north. Okay, this point represents 2 hours later. So he's gone 600 miles per hour for 2 hours. So he's gone 1,200 miles. Now, Archimedes suddenly is here. So remember, at this point, I'm going to again set up my compass, or my right northeast, and now he's going to begin to go due south. So I'm going to insert a line because that just will make sure that I'm going to do a little bit better of a job here. Okay, and I'm going to scroll down a little bit. I'm going to actually give myself a little bit more slack. Okay, and hopefully I can get this looking nice. So I'm trying to do my best because I know, folks, I don't always draw things to scale the best because for me, drawing stuff to scale, you got to get used to it's not going to be like that. And drawing stuff to scale, to be honest, is not the most important thing. In my opinion, you can disagree with me. Okay? He's going to be going at the same speed. And now, 11 a.m. to 3 p.m., that's 4 hours. And so he's going to travel 2,400 miles. I don't know how realistic this is, but he is going to travel 2,400 miles because he's going 4 hours, 600 miles an hour. Believe it or not, that's pretty fast. Basically almost supersonic. He's a pretty fast cat, Archimedes. So the red distance represents, okay, the red line rather represents the distance between the ending point, right? Because what we know is that, let me get this in a different color. This blue dot that I'm putting on now, this is where he's at 3 p.m. So at 3 p.m., I need his distance from Logan, and I also need his bearing. So remember, this is north. So I'm going to need this whole thing right here. I'm going to need to know all that. So basically, in the end, I'm going to need to figure out this angle right here. Now, right now, I can't do that because I do not know the law. I don't have enough to do the law of cosines because you need the red side to the law of cosines, okay? So basically, let's start by finding the red. So to find the red, I need the angle across from it. So I'm going to need to know this angle. And I need the other two sides. So I've got the other two sides. I now need to find the angle. So what I know is that this north-south, okay, is parallel to this north-south. Okay? And so what happens is, and I'm going to go ahead and I'm going to make a nice, like a little bit thicker line. I'll do this in a different color like purple. This here is going to be a transversal, right? It's a line. The side cuts through two parallel lines. And so therefore, these are alternating interior angles. Okay, so what that tells me is that essentially this is a 36-degree angle right here. All right. So basically, what I know is I need to figure out the distance. So I know that and I'll do this in red because that's what I use for that side. So the distance squared is equal to 1,200 squared. The numbers are going to be larger, but the idea is the same, right? Law of cosines, minus 2 times 1,200 times 2,400 times the cosine of 36 degrees. Okay? So let's see if we can figure that out. Okay, so 1,200 squared plus 2,400 squared minus 2 times 1,200 times 2,400 times cosine of 36 degrees. So we just do that in our calculator. Wow. So what we get is the distance squared is equal to 254,006.2.112. So this is about 2.5 million. Okay, and I want the distance, so I'm going to square root the answer, and I'm going to expect to see a good number of decimals here. Okay, so the distance is equal to approximately 1,593 point. I'm going to do 3 decimal places, 757. Now, when I report it, we're going to report it with 1 decimal place. So the final distance is about 1,593.8 miles. But now, for the purposes of finding that angle, right, I'm going to use all 3 decimal places, okay? So now, essentially, let me get this in purple. I'm tasked with finding this piece because I'm going to need to add those together to get the final result. Okay, so now that I know all 3 sides, remember I'm substituting 1593.757. And if you're confused why I'm using this, I talked about, I think it was either early this week or late last week, about how there's this kind of request to use 3 decimal places in your intermediate stuff. So that is the stuff that helps you find other answers, but then to report maybe 1 decimal place. And that's because remember that when you round, right, 1593.757 is not really what it is. And if you look at the calculator on the right hand side of the screen, we know that I had to cut some stuff off. So it's really a lot more than that. And it's really even more than what you see on the calculator screen. So when you round, you're accepting that your answer is not entirely right, but we accept that like it's good enough. If we don't want to go nuts with our decimals, we have to accept that we're going to sacrifice accuracy a little bit. But the more decimal places we use, the less error we get, because now what I'm going to be doing is I'm going to be finding an estimate for an angle, right, using another estimate. And so those errors begin to add up. So the more you round, the less error you have. Okay, so that's why we're going to do 3, because it's going to reduce our error. So now what I'm going to do is I'm going to find the purple. So what I know, I look across from the purple, I see 2400. So what I know is that 2400 squared equals my first side, 1200 squared, plus, now I use my 1593.757, right? So again, we know that I'm not plugging in the exact number. I'm plugging in like a good enough. Minus 2 times 1200 times 1593.757 cos theta, the thing I don't know. All right, and then we talked about how to solve for cos. You're going to be subtracting this stuff and dividing, etc. So you should get the cosine of theta is equal to, right, the cosine of our angle, 2400 squared minus 1200 squared minus 1593.757 squared, all over negative 2 times 1200 times 1593.757. So let's figure that out. Remember, we do top, then bottom, then answer. Okay, please don't cut corners, because if you do, remember that forewarning I gave you? If you cut corners and you do it your way and you don't do it right, you're going to end up doing it my way anyway, and it's just going to cost you a significant amount more time. So save yourself the hassle and kind of hook it up the right way the first time. Okay? Now remember, if you're going to divide, you really got to get this right. 1593.757. Oh, wow. Sorry, I just wanted to hit that number because it looks, I don't know what was going on there. Squared. All right, so see, that's our numerator. Let's enter it. Whoa, okay. Let's see. So I just want to make sure it looks okay. So I'm going to get, wow, 177,938.625. So I'm going to end up getting a pretty large angle here, I can tell. We're going to end up with a negative number, and that's okay. Sometimes that happens, and that doesn't mean you're wrong. Let's see what happens. Negative 2 times 1200 times 1593.757. Let's see what happens here. Wow, okay. So I get negative 3825016.8, and that's the cosine of theta. So what I need now is I need to take the inverse cosine, because if you want an angle, you always do the inverse. So 177,938 and 625 thousandths over negative 382, 5016 and 8 tenths. Okay, so again, there's no way to do this without your calculator, and I do not expect you at all, not one bit, to do this without a calculator. Okay, there's no way you can, and so it's okay. 625 divided by negative, or actually I'll save myself time, and I'll just divide by the answer to the previous problem. See what we get. Nice, here we go. So what we got to get at this point, theta is approximately 117.7 degrees. Notice I'm not, actually we should include the 3 decimals. 732 degrees. Okay. So what that means is this purple piece is 117.732. So the purple piece is that. This is 36. So to get the whole thing, I do 36 and then I add 117.732. So I'll just do plus and see how it plugs in the answer. So the bearing is 153.7 degrees. So I could do it like that, or I could do north 153.7 degrees east. Either one of these. Okay, that's the bearing. And again, you can see that if I was to set up my north, south, east, west, like I'm doing here, this whole, I'm looking up and then I'm swinging a total of 36 plus 117.732. Okay? So that is the bearing. The distance is about 1593.8 miles. And that's how we do it. So I hope that you were able to get this right. Again, this is continuing to work on our bearings problems. Kind of keep it up. Hopefully you use today to get caught up and to ask me any lingering questions before we continue to move on with bearings. So again, hopefully you got this right. You found this to be helpful. Keep up the good work. Everyone keep your head up. And remember, you can do it. All right. Thanks for watching. Have a wonderful day. And don't forget to love math.